You know, inside your eye, right this very second, there's this incredible, high-stakes plumbing system running on a microscopic scale. It's something you probably never think about, but is absolutely essential for your sight. So let's pull back the curtain on this hidden world, figure out how it works, and find out what happens when things go wrong.
It's a funny question, isn't it? But really think about it. Your eye isn't a solid ball. It holds its round shape because it's constantly inflated, not with air, but with a special fluid. And it's the pressure from that fluid that keeps your whole visual system online. Okay, so there's a technical term for this, intraocular pressure, or IOP for short. And it all, and I mean all, comes down to a perfect, delicate balance. Your eye is constantly making new fluid while draining out the old stuff. It's a continuous cycle that has to work flawlessly 24/7.
To really get a handle on this, let's use a super simple analogy. Just picture your eye as a sink. You've got a faucet that's always on, always running. And then you've got a drain that's supposed to let out just the right amount of water to keep that sink from overflowing. This one idea, the eye as a sink, is pretty much the key to understanding everything else we're about to talk about.
All right, so let's start at the beginning, the faucet. Where does all this fluid, which is called the aqueous humor, actually come from? Well, the production process is an incredible feat of biological engineering.
The whole operation starts in a structure called the ciliary processes. Imagine these tiny folded-up tissues packed in to create this huge surface area, all for one single purpose, pumping out fluid. And this isn't some passive leak, oh no. This is a very active, energy-hungry manufacturing process. So how does this faucet actually run? It's a brilliant three-step process. First, the cells in your eye actively pump out solutes. You can basically think of them as tiny salt particles. This creates a really powerful chemical imbalance. And you know, because nature just hates an imbalance, water immediately rushes in to even things out. And boom, just like that, you have a fresh supply of eye fluid. This whole system is run by a crew of microscopic heavy lifters. You've got these tiny pumps that act like the engines, driving the entire process. Then there are specialized gates called aquaporins that only let water through. And finally, you have an enzyme that acts as the balancer, helping to create the salt needed to keep the whole act going. It's a perfectly coordinated little team. And get this, your eye's faucet doesn't just run at the same speed all day long. In fact, the production of this fluid is up to 2.5 times higher when you're awake compared to when you're asleep. It's an incredibly dynamic system that's constantly adjusting to your body's own daily rhythm. Pretty amazing, right? Okay, so the sink is filling up with water from the faucet. Now we have to talk about the drain. Because, let's be honest, if that drain doesn't work perfectly, that constantly running faucet is going to cause a massive problem.
The main drain has a fancy name. It's called the trabecular meshwork. But honestly, the best way to picture it is as a tiny biological coffee filter. It's this sieve-like structure, and its whole job is to let the fluid out while keeping other things in.
I mean, it is just an amazing piece of biological architecture. It's this lattice made of collagen, and its pores actually get smaller and smaller as the fluid gets closer to the exit. This intricate design is what controls the rate of drainage with incredible precision.
But the most crucial part of this whole filter is the final layer. It's called the juxtacanalicular tissue, or JCT. This is the bottleneck. This is the spot that provides most of the resistance to the fluid trying to get out. In a healthy eye, this resistance is perfectly tuned, which makes the JCT the ultimate gatekeeper for the pressure inside the entire eye.
So, we've seen the faucet, we've seen the drain, everything is in perfect harmony. Now, for the most important part of this whole story, what happens when that drain starts to clog up and the whole system starts to break down?
Well, unfortunately, as we get older, this drain can become a lot less efficient. The specialized cells in the meshwork can start to die off. Cellular gunk, what scientists call extracellular matrix, can build up and start to clog the pores. And the tissue itself can just get stiffer, less pliable, making it way harder for fluid to pass through.
And the consequence of that is, well, it's pretty simple and direct. The faucet is still running, but the drain is clogged. The fluid has nowhere to go, so the pressure inside the eye, that IOP, it starts to rise.
And this, right here, is the critical takeaway. While the faucet's flow rate matters, it's the resistance in the drain, that clogged filter, that is the single biggest factor in determining your eye pressure. Pretty much every problem comes back to this one critical point of failure.
Now, the body is clever. It actually has a backup drain. The main one, that trabecular pathway we've been talking about, handles about 80 to 90% of the outflow. But there's a secondary route, the uveoscleral pathway, that handles the rest. What's so fascinating is that different glaucoma treatments target these different pathways. Surgeries often aim to physically clear out the main drain, while certain eye drops work by propping open this alternate overflow route.
So why does any of this matter? Because that increased pressure, it isn't harmless. It physically pushes on the delicate optic nerve at the back of your eye, slowly and irreversibly damaging it. And that damage, that is the disease we call glaucoma, one of the leading causes of blindness in the world.
Okay, so let's bring this all together. This entire microscopic plumbing system, from the faucet all the way to the drain, is fundamentally about one thing and one thing only: preserving your ability to see.
The healthier vision is literally hanging in this microscopic balance. Too much fluid coming in, or, much more commonly, too little getting out, and the whole system is thrown into chaos. It's a perfect equilibrium that your body maintains flawlessly for decades, until, for many of us, it just can't anymore.
So, if there's one thing you take away from all this, let it be this. Healthy vision depends completely on the smooth flow of this fluid. That resistance in the drain is almost always the critical failure point. And when that happens, the resulting high pressure can cause damage you can never, ever get back. Understanding how this works is truly the first step in protecting our sight.
And that really leads to a final thought. This tiny, perfect system runs completely automatically, protecting our ability to see the world without any conscious effort from us for most of our lives. Its gradual failure is such a powerful reminder of just how intricate and ultimately how fragile the biology that gives us the gift of sight truly is.